Ray just photographed something that shouldn't exist. Multiple telescopes, different nights, completely different setups, all showing the exact same impossible thing. And I'm not talking about some blurry dot that could be anything. I'm talking about a crystal clear image of an object from outside our solar system doing something that's never been documented in the entire history of astronomy.
I think we hit the sweet spot where we are going to get the perfect data for Comet 3 Atlas. So last night was a clear night, moonless night, also very clear from the atmosphere standpoint. So it's a beautiful night to take pictures of Comet 3 Atlas.
Ray's astrophotography has captured something that, by current understanding, should not exist. Observations from multiple telescopes, taken on different nights with entirely different setups, all reveal the same anomalous structure. This is not a vague or ambiguous signal, nor a blurry point open to interpretation. The images are clear and consistent, showing 3I Atlas, an object from outside the solar system exhibiting behavior that has never been documented in the recorded history of astronomy. At the center of every frame appeared a compact, stable nucleus, showing no signs of disruption or fragmentation. The core remained sharply defined, anchored precisely where orbital calculations predicted it should be. Extending from this nucleus was a feature that initially resembled a conventional cometary dust tail, but that resemblance quickly faded. A second, fainter structure was also present, oriented in a direction inconsistent with normal comet behavior. The resulting geometry did not align with established models. Beyond this, an even more unusual feature emerged, a cone or funnel-like morphology trailing the object, maintaining a coherent shape across multiple nights of observation. During long exposures, background stars stretched into trails, while the object itself remained sharply fixed. A contrast that effectively eliminated explanations based on motion blur, tracking errors, or processing artifacts. The structure was persistent, stable, and undeniably real. What made this immediately troubling wasn't just that the structure was odd, but that it refused to change. Transient effects come and go, jets flicker, outbursts spike and fade, but this didn't. The same morphology showed up again and again across different observers who had no reason or ability to coordinate their results into a shared illusion. Different cameras, different telescopes, different skies, the same geometry. At that point, the question stopped being whether the data was real and became why this kind of structure existed at all. Because even before you bring in spectroscopy or orbital mechanics, the visuals alone were already outside expectations. This was not the first time 3I Atlas had caused unease. Long before these images were captured, it was already raising eyebrows. It had been flagged as strange in professional observations months earlier. Spectroscopic studies conducted before perihelion failed to detect the usual cometary gases, molecules like hydroxyl and cyanogen, that are effectively the fingerprints of sublimating ice. By standard definitions, an object without those signatures shouldn't be active. It should behave like a largely inert asteroid, perhaps shedding a little surface dust, but fundamentally dead. That classification alone set up a problem, because what was now being observed was anything but inert. After perihelion, instead of fading or remaining unchanged, Atlas brightened, not subtly, significantly. Jets appeared, dust production became sustained and continuous. This wasn't a brief crack in a crust releasing trapped volatiles in a chaotic burst. The activity was smooth, stable, and persistent. That sequence matters. You don't scan a fuel tank, find it empty, and then watch the engine run anyway. The sun doesn't manufacture new chemistry out of nothing. It only activates what's already there. If the object truly lacked cometary volatiles before perihelion, then post-perihelion activation shouldn't have been possible. Yet it happened. This is where the contradictions begin to stack. X-ray emissions were detected from the object, emissions that are well understood in cometary physics. They occur when the solar wind interacts with neutral gas in a comet's coma, producing characteristic charge exchange signatures. This process is not exotic. It's been observed for decades. But it requires gas, real gas, which means that at least at some point there was a gaseous coma interacting with the solar wind. That fact alone directly contradicts the earlier spectroscopic claim of no cometary gases. Both observations come from world-class instruments. Neither is easily dismissed, and they cannot both be wrong in a way that conveniently resolves the problem. As these inconsistencies accumulated, one of the people who began organizing them systematically was Avi Loeb. Rather than treating each oddity as an isolated curiosity, he approached 3I Atlas as a case study in compounded improbabilities. Over time, he identified 15 separate anomalies associated with the object. Not interpretations, observations, measurements, geometric facts. Each one, taken alone, might be brushed aside as coincidence or statistical noise. Taken together, they form a pattern that is difficult to ignore. The first cluster of anomalies involves geometry and orbital alignment. The trajectory of 3I Atlas through the solar system lies within about 5 degrees of the plane in which the planets orbit. For an interstellar object arriving from a random direction in three-dimensional space, that alignment is extremely unlikely. The odds are on the order of a few tenths of a percent. That doesn't make it impossible, but it does make it notable. The timing of its passage relative to Mars and Jupiter adds another layer. Its approach distances line up in ways that appear unusually well matched to planetary positions, coincidences that are statistically uncomfortable when stacked together. One of the most striking orbital coincidences involves Jupiter's Hill region, the region where Jupiter's gravity dominates over the Sun's for nearby objects. The predicted closest approach distance of 3I Atlas happens to fall near that boundary. Again, not impossible, but this is now several low-probability alignments deep. Then there is the sunward pointing anti-tail itself, a narrow, tightly collimated jet extending roughly 1,000,000 kilometers, visible both before and after perihelion, pointing toward the Sun. Anti-tails exist, but they are typically broad, diffuse, and heavily dependent on viewing geometry. This one is sharp and persistent. Even more unsettling is how the object's rotation appears to be oriented. Analyses suggest that its rotation axis was aligned to within about 8 degrees of the sunward direction at large distances. Natural bodies tumble. Their spin axes are generally random. This kind of alignment is rare. The observed wobble in the sunward jet implies that the jet originates very close to the rotation pole, another precise configuration layered on top of an already precise orientation. And then there is the geometry of the jet relative to the object's orbital deflection. At perihelion, the object's trajectory was bent by gravity by roughly 16 degrees. The opening angle of the jet is about 8 degrees. That relationship allows the pre- and post-perihelion jets to line up in a way that preserves their sunward orientation across the deflection. The numbers fit together too neatly to ignore. There is also a more controversial geometric coincidence. The incoming direction of 3I Atlas lies within about 9 degrees of the direction of the famous 1977 WOW signal. This alone proves nothing, and it is important not to overstate it, but as one more low-probability alignment in an already crowded list that contributes to the overall unease rather than resolving it. Composition adds another layer of strangeness. Spectroscopic data indicates an unusually high ratio of nickel relative to iron in the gas plume, far outside the range seen in known comets. At the same time, water, the dominant volatile in typical comets, appears to make up only a small fraction of the detected material, on the order of a few percent. That alone challenges the object's classification. A comet without water as its primary volatile is already an outlier. Combine that with nickel-rich emissions, and the picture becomes harder to reconcile with familiar formation environments. Physically, 3I Atlas is also extreme. It appears larger and faster than previous interstellar visitors like Oumuamua and 2I Borisov. Objects of that size and velocity should be rarer, yet here it is. Polarization measurements of reflected light show values unlike anything documented for known comets, implying unusual surface or dust properties. Near perihelion, the object brightened rapidly and took on a blue color, brighter and bluer than expected for a natural cometary body under solar heating. Then there is the issue of acceleration. The object exhibited non-gravitational acceleration near perihelion that cannot be fully explained by standard outgassing models. And throughout all of this, the sunward jet persisted. Even after the object's orbit was deflected by gravity, the jet continued pointing toward the sun. That behavior is inconsistent with conventional coma physics, where dust and gas dynamics are expected to respond more sensitively to changes in trajectory and orientation. What do these anomalies suggest? At minimum, they suggest that the categories we use, comet and asteroid, may be insufficient when applied beyond our solar system. Every comet we have studied in detail formed from the same protoplanetary disk, under the same elemental ratios, radiation environment, and thermal history. Interstellar objects did not. They are products of other stars, other disks, other chemical inventories. It is entirely possible that they behave in ways that our locally derived models simply cannot predict. This brings the story back to those early morning images. The visuals were not the conclusion. They were the warning signs. They told us something was off before the data tables and orbital fits caught up. And now, as the object fades and recedes, the opportunity to resolve these questions is slipping away. 3-eye Atlas is natural until proven otherwise. That much is clear. But natural does not mean understood. Right now, we know what it is doing. We do not know why. And acknowledging that gap is not a failure of science. It is the beginning of it.